Hello guys. So in this video we're going to talk about trees in DSA. So let's start. So welcome guys, welcome to my channel and welcome to a brand new video as well. So in this video I'm not going to code anything or explain you any coding implementation. Rather I'm going to show you as well as explain to all of you the most important as well as the basic concepts in trees. So now before starting the video, I would like to request all of you, those who are new to my channel as well as those who haven't subscribed to my channel yet, then please ring the bell after subscribing to my channel so that you never miss an update and so that it motivates me to create more content like this in the future. So now with that being said, let us jump into the video straight away. So to begin with, what are trees in data structures and algorithms? So trees in DSA are basically a collection of nodes in which the nodes are arranged in a hierarchical fashion. So what do you mean by a hierarchy? So as you can see on the screen I have one tree. So this is a very generic tree as you might see. So in this example we have the first node A which is connected to a set of other nodes in the hierarchical fashion. So A is connected to B, C and D. Furthermore, B is connected to E, C is connected to F and G, D is connected to H and so on. So as you can see, this forms a hierarchy of nodes in which the first node is having the highest hierarchy, or it is sitting right on the top level, but the other nodes are right below it. For example, B, C and D belong to the next level of the first node. Similarly, E, F, G and H belong to the subsequent level and so on. So this kind of data structure is known as a tree. So like linked list, in tree also we can travel bidirectionally, but we cannot travel in a cycle, as is already shown in this figure that you can travel from A to B, and also if we make the connection bidirectional, then we can travel from B to A as well, and similarly for the other nodes, but we cannot travel in a cycle. Like as you can see, if we travel from A to C and then from C to F, we cannot travel from F to E and then from E to B and to A. So we don't have the link between the nodes E and F. So a cyclic kind of travel is not possible inside a tree. So that is the basic definition of a tree in DSA. So now let's move on to see some of the other concepts which we have in trees. So in tree, the most important node is called the root node. It is the first node from which all the connections are made onto the other nodes. So in our case, the node having the label A is the root node. So it is connected to other nodes like the node B, node C and node D, which are further connected to some other nodes. So as you can see, the root node or the node having the label A is connected to the node B, C and D. So now let's come to the first term which we have to learn. So the first term is the parent node. So for example, if you consider this region over here, then our root node or the A node is our parent node, because from it we have the connections to the other nodes B, C and D. So in this case, B, C and D are going to be our child nodes, and A is the parent node of these three nodes. Now we can take this example also. So in this example, the node C is the parent node and the nodes F and G are the child nodes, because C is connected to F and G. And now let's move on to the next term which we have to learn. So the next term is the leaf nodes. So what are leaf nodes? So leaf nodes in a tree are basically the nodes from which we don't have any further connections. As you can see in this diagram of tree over here, that the nodes I, J, K and L as well as the nodes G and M are the leaf nodes, because these nodes don't have any child. So these are the ultimate nodes which are present in this diagram of tree which we have on the screen. So now moving on to the next important term. So now let us see what are siblings. So two or more nodes in a tree are said to be siblings if they have the same parent. So as you can see in this diagram of a tree over here, the nodes B, C and D have the same parent, that is the root node itself, which is the node A. So in this case, B, C and D nodes are said to be siblings because they have the same parent as we have in real life. So in real life also, if you have a sister or a brother, then you two are said to be siblings because you have the same parents, you share the same parents. So this is another example. So in this case, we have three siblings. So in the previous case, we also had three siblings, and this is another example. So the nodes I, K and J are siblings because they have the same parent node, that is the node E. So now moving on to the next important term. So what are ancestors? So what do you mean by ancestors in a tree? So ancestors are basically the nodes which are present before a particular node if we follow the same path from the root node until that node. So what this basically means is that if you want to find out all the ancestors of a particular node in a tree, then you have to follow the path right from the root node till that node. And if we follow that path, then all the nodes except that particular node are known as the ancestors of that node, of that given node. So now let us take one example. So as you can see in this case, if we consider the node labeled E, so for finding all the ancestors of this node E, we have to follow this path, that is the path right from the root of this tree till this particular node. So the nodes which we encounter in our travel is the node A, that is the root node, and the node labeled B. So the ancestors of E are the nodes A and B. Now in the same way, if I want to give another example, or if I want to explain another important term, which is descendants. So if we consider the node B over here, then the descendants of B are said to be all the nodes after that particular node, which are connected to it either directly or indirectly. So if we take the example of B, then the first node which is connected to it is the node E. Further connected to the node E are the nodes I, J and K. So all these four nodes are said to be the descendants of the node B. So the descendants of the node B are the node E, the node I, node J and node K. And if I want to say it in another way, then I can also say like that. What are the predecessors of the node E? So one important term is predecessors. So the predecessors of the node E are the node B and node A. So the predecessors as well as the ancestors are basically synonyms. So as you can say, so the ancestors as well as the predecessors of the node E are B and A. So this is another example. So in this case, if you take the first node, that is the root node, as the parent node, then D is going to be the child node. It is one of the childs of the root node, that is the node A. Now let's move on to the other important terms. So the next term in our list is grandparents. So when do you call a node is a grandparent? So a node is called a grandparent if it is connected to some particular nodes through one node, which is actually the parent. So what that basically means. So if you take this example, then you will be able to see that we have pointed out two nodes which are at the same level, that is the nodes E and G. So the nodes E and G are both indirectly connected to the root node, that is the node A. And the node A has three children, so two of those are B and C. So we can also say that E is the child of the node B and G is the child of the node C. And B and C are the children of the root node. So if you look carefully, then you can see a very interesting similarity with our blood relations in real life also. So as B and C are the parents of the node E and F respectively, and A is the parent of B and C node, then we can say that both the nodes E and G are the grandchildren of the root node, that is the node A. In this case, the root node or the node labeled A is called the grandparent of E and G. And subsequently, the nodes E and G are called the grandchildren of the root node, that is the node A. So now let's move on to the next important term, which is what is the degree. So what do you mean by degree in trees? So the degree of a particular node is basically the number of nodes which are connected to that particular node. So in this case, as you can see in this example, the node C has two nodes connected to it, which are F and G. So the degree of C is said to be 2 in our case. So now let's just take another example. So if you consider this node over here, that is the node labeled E, then you can see that it has 3 children, that is I, J and K. So the degree of E is said to be 3. Now let us take the example of the root node. So if you want to find out the degree of the root node, then you have to see how many children the root node has. So in our case, we have the children as B, C and D. So as A is connected to 3 nodes, the degree of the root node is said to be 3. And the next important term is the degree of a tree. So what is the degree of a tree? So the degree of a tree is the maximum degree of the nodes which are present in the tree. So if you look carefully, then the maximum degree which a node possesses in this tree is 3. So we have 2 examples for that. So the first example is the root node, which is the A node. It is having the degree 3, as well as the next example is the node E. So A is connected to 3 nodes, so its degree is 3. So the maximum degree is 3, and that's why the degree of this tree is 3. Now let's move on to the next important term. So what is a level? So a level in a tree is basically the hierarchical levels which are present in the tree. So what does that mean? So if you observe carefully, then a tree is having a hierarchical structure. So if you move from the root node till the next level of nodes, then you find B, C and D. And if you move from any of these nodes to the next level, then you will find the nodes E, F, G and H. And subsequently will find the nodes I, J, K, L and M. So this kind of structure basically forms a sequence of levels. So A is present at the first level, B, C and D at the second level, E, F, G and H at the third level, and the rest of the nodes, that is the nodes I, J, K, L and M, are present in the final level, that is the fourth level. So the nodes present at the final level are all leaf nodes, if you can see clearly. So the total number of levels which are present in this tree are 4. So if you exclude the nodes present in the final level, then you have 3 levels. That is the first level, second level and the third level. Now let's move on to the next important term, which is the depth of a node. So what do you mean by the depth of a node in a tree? So if you consider a particular node, then the depth of that node is basically the total number of paths which you have to traverse from that particular node till the root node. So if you start right from the root node until the given node, then the number of transitions you have to make via nodes is said to be the depth of that particular node. So for example, if you take the example of this node over here, which is C, then if you were to traverse from the root node till this node, then you have to travel only once, that is one time. So the depth of this node C is said to be 1. Now let us take some other examples. So if you take the example of F over here, then you have to start from the first node, that is the node A or the root node. So first of all, from A you will move to C, and from C you will move to F. So you are doing 2 transitions. So the depth of the node F is 2. Now let's take the example of the node labeled J. So now let us start from the root node. So from A you will go to B, from B it will go to E, and from E it will go to J. So in the total process we took 3 transitions, so the depth of J is said to be 3. And now the important case we have here is the depth of the root node. So what is the depth of the root node? As the root node is present in the first level, so the depth of the root node is 0, because it is the first node from which all the other nodes are originating. So the depth of the root node is 0. So now let us move on to the next important term, which is the height of a particular node. So what is the height of a node? So the height of a given node in a tree is said to be the number of levels which you have to traverse or pass from the final leaf node. So what does that mean? So now let us take the example of the node C. So if you want to find out the height of the node C, then you have to take the leaf node which is present indirectly to C. So the leaf node in our case is the node L. So first of all you will have to travel from L to F and then from F to C. So we are making 2 transitions, or we are covering 2 levels. So the height of this node C is 2. Now let us take another example. So what is the height of the E node? So the leaf node over here is J, K and I. So if you were to make transition from any of the 3 nodes, then you have to travel only once, or you have to cover only one level. So the height of the node E is 1. And similarly, as we had seen in the case of the root node, as we had seen the depth of the root node, let us find out what is the height of the root node. So the height of the root node in a tree is basically the number of levels which we have. So the furthermost leaf node which we have are I, J, K, L and M. So if we were to travel from any of these nodes, let us travel from L. So from L we have to move to F, from F to C, and from C to the root node A. So we are making 3 transitions in total. So we can say that the height of the root node in our case, in the case of this diagram over here, is 3. So now this was all about the important terms which you can encounter in trees whenever you are learning about them or are solving any problem. So now let us see what is a binary tree. So trees can be of many types. So we have binary trees, ternary trees, as well as the other types of trees. So one of the most important as well as the commonly used trees is the binary tree. So as the name suggests, in binary trees we have at most 2 children. So if you consider a parent, then we have 2 children. So it can also have 1 children. So basically a binary tree can have at most 2 children. So a particular node, if you consider in a binary tree, then it will have at most 2 children. It can also have 0 children as well as 1 children. So at max, the number of childs which a particular parent can possess in a binary tree or a particular node can have in a binary tree is 2. So as you can see in this diagram over here, we have one example of a binary tree. So in this case also, the node A is the root node, and we have attached to it 2 other nodes B and C. So D and E are the children of the node B, and B and C are the children of the parent node, that is the root node A, and similarly for the other nodes. So this is one example of a binary tree. And now let's move on to the other types of trees. So as you might have already guessed, in the case of a ternary tree, any particular node which is present in that kind of a tree can have at max 3 child nodes, and for the example of a tree with at max 4 nodes also. So in order to generalize, we can have n-ary trees. So in n-ary trees, a particular node in that tree can have at max n number of child nodes. So as you can see, this is the case of a generic tree over here. So there is no limitation of how many number of nodes are attached to a particular node in this case of a tree. So a particular parent node or a node can have at max n number of child nodes or nodes connected to it. So this is an example of an n-ary tree. So that's it from this video, guys. That's it. I hope you enjoyed it. If you really enjoyed, then don't forget to like this video as well as share this video with your friends, and also comment down in the comment section what kind of video you want me to make next. And also don't forget to subscribe to my channel so that you never miss an update. So see you all in some fresh video. Until then, stay safe and keep exploring.